Well, thank you so much. So we just get started. I'll confess that this is probably my first talk in front of a live audience since 2019. I'm guessing you know why. So I discovered while rehearsing that giving talks is a skill that I need to relearn, so do bear with me if I'm clumsy or anything. So in this talk, I'll be giving you a quick overview of all the cool features, well, not all the cool features, but some of the cool features that we've been working in .NET 8. So let me start with some mandatory introductions. So as Dylan said, I'm Eirik. I'm a software engineer at Microsoft. I'm based in London. And I'm working in the .NET Libraries team. I've been there for about 4 years now, where I maintain system.collections, system.link, system.json, and a few other things. For a bit of background, I enjoy functional programming and C# a lot. And actually, C# is I got into .NET about 12 years ago. Been pretty active in that community. I've given a talk in the London C# meetup before, but this is my first time in the London .NET meetup. I've authored a number of open source C# libraries, done a bunch of stuff in C#. But now, with that out of the way, it's on to the subject of the talk, .NET 8, or .NET, right?
.NET.
.NET. So that's .NET is the annual release of .NET. It's going to be released in November. It's a long-term support release, which means that it comes with 3 years of security and support, security updates and support. For those of you who don't know, long-term support releases come out biannually. So to give you an example, .NET 6 and .NET 8 were long-term support releases, whereas .NET 5 and .NET 7, which came out last year, come with standard term support, which is 18 months of support and security updates. This Tuesday, we actually released .NET 8, .NET RC2, which is the final release candidate ahead of GA in November. So before I dive into the content, I'm going to start with a quick disclaimer. .NET 8 ships with literally hundreds of features, some of which I'm not even aware of. We're a big team. So I could not possibly cover every important feature in this one talk. So instead, this is going to be an opinionated walkthrough of some of my favorite features. So my apologies if your favorite feature that you're aware of isn't listed there. Obviously, there's .NET Conf coming up in November, so if you want to find absolutely everything, almost, about .NET 8, then subscribe to that, it's free. And I'll be speaking with it. So with that, let's get on to it. I'm going to get started with performance, since it's probably the most important improvement that you get once you update to .NET. Because it's something that
we should probably stop calling it .NET in case it sticks. Yes. Yeah, this will go on the internet and we'll get hate mail. Yeah.
I dropped the name.
So performance is something that your applications will be able to take advantage of just by updating the SDK without making any changes to your code. How many of you are aware of this article? Show your hands. How many have read this article end to end? So in case you don't know, this thing contains a lot of content, as you can see here. In fact, this is a sort of an annual tradition that my colleague Stephen Tell was doing around every September, ahead of the upcoming release. And as you can see, there appears to be a sort of exponential trend in the increase of pages with every yearly release. And I'm guessing that in .NET 9, there will be 400 pages in the performance blog. So I tried taking a screenshot of the table of contents. I couldn't fit, so I had to split it up. But as you can see, the performance improvements pretty much cover anything that you can imagine across the product. So all these things combined should probably deal significant performance improvements. Well, that being said, if I could just narrow down that previous article into just like 3 must-know things, I think these 3 ones are the ones to keep. So first of all, we have dynamic PGO. PGO stands for Profile Guided Optimization, which in very naive terms, it's a JIT technology that profiles application code at runtime and uses that data that has been gathered in the initial runs to drive subsequent optimizations as the JIT generates new tiers of the same code. It was shipped as an optional feature in .NET 7, and with .NET 8 we've substantially improved it to the point where I'm happy to say that it's actually the default and it's turned on with .NET 8, assuming that you're running your application in Coursera. I would say that this is easily the most impactful performance improvement that we're shipping this year. Then we have, the GC. If anyone has published .NET applications, you might know that GC can typically be configured into two different modes, workstation mode and server mode. Workstation mode is primarily concerned with optimizing for memory usage, whereas server mode is primarily optimized for scalability and throughput. But one issue with server mode is that it actively pre-allocates dedicated heaps for every logical core in your machine. And this can result in increased memory usage upfront in your application. I know that in the past this has created issues for me, especially when trying to publish applications in containers, although that's not necessarily the case nowadays, but generally speaking, server mode will have these issues. So with .NET 8, we've actually shipped an optional flag to be turned on for server mode, which essentially supports dynamic heap counts, which can decrease or increase over time and on demand, depending on your application requirements. It's currently off by default, but it's actually turned on by default if you publish your application to Native AOT. And in our internal benchmarks, we actually found that this new dynamic adaptive mode actually occupies a sweet spot between memory efficiency and throughput. So we're actually cautiously optimistic that this might be the default that we turn on in future releases. Finally, .NET 8 adds support for AVX 512 enabled hardware, both in the JIT and via exposing managed vectorization APIs. We've updated several performance critical libraries, and we've taken advantage of we've made several performance. You say that again? In breath. We've updated many of our libraries to use the new AVX 512 stuff. I guess that's the way to put it. And collectively, these improvements seem to adapt. We've already collected user reports from the wild, where simply by virtue of them updating to .NET 8, they get substantial performance improvements. So it seems to me that this is going to be an important release from a performance perspective. So with performance set aside, now you know everything about .NET performance. No, I don't know anything about .NET performance. Let's go over Native AOT. So Native AOT is the ahead-of-time compiler toolchain for .NET. It lets you publish minimal, self-contained native applications, and it first became available with .NET 7. The benefits of Native AOT is that it lets you publish really small applications in terms of this footprint. It offers faster startup time, and it gives you a lower memory footprint. But it obviously does come with disadvantages as well. The key thing to keep in mind is that it doesn't come with a JIT. And I think every other disadvantage listed in this slide effectively comes as a corollary of that statement. So API reflections are limited. Some APIs you can never even call because under wraps they require dynamic code generation. You cannot use things like reflection emit. You cannot use dynamic methods. You're not able to use system link expressions. And of course, you won't be able to get access to dynamic PGL because that requires having a JIT. And by extension, that means that if your application depends on libraries, and these libraries do perform unsupported reflection or do perform runtime code generation, chances are your application will work because the library itself will need to get updated to support Native AOT itself. And that is typically not an easy exercise. The library authors will typically need to replace their reflection components with an equivalent source generator. And I guess another thing that might be worth mentioning is that if you have an application that makes particularly excessive, particularly abusive use of generics, that has the potential to regress your application size because more generics means more native code that needs to be generated ahead of time, which may or may not be needed by your application at runtime. I've been bit by this personally, so now you know. In terms of what we did for Native AOT in .NET 8, first of all, we focused a lot on size reduction. So we made many changes to the runtime itself. We made many improvements to libraries so that unnecessary code doesn't get caught up by a trimmer, removing dependencies where they're not needed. And for one of them, our benchmark apps, which basically just prints hello world, we've been able to reduce size down from 2.7 megabytes in .NET 7 to 1.2 megabytes in .NET 8, which means that we can now fit it in a floppy disk. But it's only going to take a little while. We're also supporting more platforms. So now you can use Native AOT in macOS, both in Apple Silicon and older Intel Macs. And that should probably explain why I brought a Mac with me today. We also offering preliminary support for iOS. We also made heavy investments into getting ASP.NET Core to work well with Native AOT. That wasn't the case in 7 necessarily. Now we offer support for minimal APIs. We don't offer support for MVC yet. That's going to come in a subsequent release. We made improvements in ASP.NET Core's interoperability with the system.text.json source generator. And finally, in the libraries front, we authored a bunch of source generators to make certain components work well in AOT. So we shipped a configuration binder source generator. We published a source generator for the iValidate options abstraction, and we invested heavily into improving the performance and reliability of the system.text.json source generator. Whew. And with that, let's head to the demo. So you'll see here that I've got VS Code open. VS Code uses the brand new C# dev kit, which is the other reason why I put an app with me today. But basically now you can actually work with solutions on your VS Code. Yay. So I'm going to navigate to this ASP.NET AOT demo application. First of all, let me show you the project configuration for the targets .NET 7. The application itself is pretty straightforward. It's defining a web application, it's doing a bunch of JSON configuration, and it's exposing a couple of endpoints using minimal APIs. And it defines a model that, if you've been watching the demos you've seen before, it defines a model for to-dos. And finally, it declares a source generator for JSON to tie it all together from the serialization perspective. If I try to run this, of course, in .NET 7, it will eventually. I can now start hitting this endpoint, and I will get some JSON. Nice, I guess that means that the application is working. But what should happen if I try to run this, to publish this as an AOT application? So if I enable this property in my project configuration and I run .NET publish, I guess if you remember my slide from before, because this is macOS, this will actually fail, and it will tell me that, hey, the current platform doesn't support OS 10. However, if I try to publish the same application on Windows, it might have succeeded compilation because AOT is supported there nominally. However, I will be getting a bunch of warnings because a number of ASP.NET Core APIs depend on unsafe reflection, and therefore it would compile with a lot of warnings, and if I try to run the application, that would crash. So you can't see this here with this laptop. So let me see what happens now if I try to change this to .NET 8. Let me over to the program. And you might notice now that the same program has now shown a couple of warnings that didn't exist before. First, in the JSON configuration callback here, it's complaining about this add context method. It's saying that it's obsolete, and to register a JSON serializer context, I would use the typing for resolver or typing for resolver chain properties. So let me just do that. So this guy here is a new property that we shipped in .NET 8. If I hover over it, you'll see that it's just a list of JSON typing for resolvers. And the purpose of this thing is that it's for multiple components within your ASP.NET Core applications to register different source-generated content. So you can register your own source-generated metadata for your own model types. ASP.NET Core is registering its own metadata for its own internal types. and so on and so on and so forth. So we've replaced it with a composable module that makes this thing possible. So if I just append to this list my to-dos context, which, as a reminder, is just the source generated metadata for my module type. This is how you can now register source generated metadata in your ASP.NET application. Secondly, there's another warning here. So as part of this module, I've actually declared an enum called status, and I've declared that this should actually be serialized as a string. This is now a warning, and the reason why it's warning is that it's saying that actually this converter thing that you're using is not supported in Native AOT, and it recommends that I replace it with a generic variant, which has just been added. And the purpose of the generic variant is that it actually doesn't require unsafe reflection in order to work. So if I just do that, where I'm just passing the type of the enum in its angle brackets, then the warning will not go away. So if I try to publish this again, this will first compile. And I'm hoping it doesn't try to download any new media packages, which is likely. I am connected to the internet. I reckon it's kind of slow, so that might be causing this. But anyway, what will happen is that it will bring the project, it will run the trimmer, then it will run the AOT compiler to generate the native code for the application. This hasn't been as slow. Like, they should have finished by now. So I'm guessing, awesome. So it produced the DLL, now it's generating native code. This is probably the longest step, because obviously it needs to do all its magic. And eventually, I will get a native binary in my artifacts folder.
So when you say native binary, that's a single file that you can put on a machine with no .NET runtime.
No .NET runtime.
And it works.
Assuming it's the same architecture as
Yeah.
you specified.
So you could give that file on a USB drive to anyone in here with a Mac, and they could just run it, even if no .NET installed.
Yeah, assuming it's
Yeah.
Apple Silicon. Right? Yeah, so that would work. Thank you for that.
Cool.
You just go full circle.
Say again?
You just go full circle back and hard code.
Yeah?
Pretty much. So if I run that now, well, I'm getting some logs, and if I refresh this, well, you see that the timestamps are updating, so everything seems to be working. I guess I can even, here. Did it crash?
No, 404, you don't have it to do 0.
Oh, sorry. Gotcha.
Yeah.
So I guess that concludes the demo. Right.
How big is that executable?
So that executable is around 1. No, I need to double check. So that executable is not as small as you would have gotten in under ideal situations, because if you want to get it really small, you need to call a slim builder. I didn't want to show you that because it's not a prerequisite for the demo. But if I actually show you the size of the thing as it is without this change, it should be 15 megs, and I think if you do the slim builder, a bunch of stuff will get trimmed away and it will get even smaller. I don't have I can run it again. Megs.
Okay.
Cool.
All right, so I guess this brings us to the elephant in the room. Do I need to use native AOT? Do I need to care about native AOT? And well, the answer really depends on what you're trying to build. If you're trying to create a small console app like a CLI, startup time in CLIs is important. I would think, and so like native AOT is ideally suited for applications of this kind. Also, if you're publishing a small microservice or a containerized application, using native AOT should generally result in reduced images. So definitely something to try about. But on the other hand, if you have a monolith or any sort of long-running server application that has like a huge transitive dependency graph of NuGet packages, then chances are that Native AOT might not be right for you. And the reason for that is, at the moment, in the year of our Lord, 2023, there's a very good probability that some dependency in your dependency graph still does unsupported reflection, and you will not be able to get that component to run in Native AOT, assuming that you're actually calling it to. But at the same time, even if you are able to kind of go through the cost of migrating your monolith to Native AOT, you will probably be getting diminishing returns from the perspective of both application size and also probably the startup time doesn't matter as much if you're using a monolith. So again, Native AOT is exciting from a technical perspective, but the answer for you may well be that you don't need it. So I think to quote a colleague of mine, Native AOT support is a dream, probably more. Many libraries don't support Native AOT yet. Many Microsoft libraries don't support Native AOT yet, but we're working on it. Like, this is a high priority for us. We're trying to get as many libraries as possible to have out-of-the-box support for Native AOT. And it will probably take a few more releases before we get there. So with that, let's move on to our language, our favorite language in .NET. And I'm just going to, should I show you this slide because it's a demo? So I'm going to go back to my VS Code instance. I don't need this, I don't need that. And I'm just going to go to this other project. I'm going to go to this primary constructors file. So primary constructors, new exciting feature. I'm really excited about it. But it may well be that the thing that I show you here might not seem entirely new, especially if you work with C# records in the past, and especially positional records. Like, if you've used positional records, you've probably already seen this. This is basically taking the idea behind positional records and lifting it to basically arbitrary types. So you can apply it to your classes, your structs, and whatnot, with some asterisks. So here, I've actually defined the laziest class hierarchy you could ever imagine. I don't care what it actually represents. I only care that I have a class hierarchy with some properties and some constructors and some methods. So let's look at the base class and take a look at what it actually does. It defines a few properties. It defines a constructor. The constructor takes a few parameters, and there's a bit of boilerplate here where I'm basically just mapping parameters to properties. And one might actually think, if you've used other languages especially, that some of that boilerplate could have been eliminated. And primary constructors precisely come into play for that reason. I'm already getting a suggestion here from the fixer to convert this to use a primary constructor. So I can get the tooling to show you what it looks like for me, so I don't need to type anything. So lo and behold, what the fixer will be doing is that it will lift the constructor definition up to the class definition, including the constructor parameters, and then it will be initializing the individual properties by mapping to the parameters at the property definition side. So we've saved ourselves quite a few lines of code here, which, from my perspective, is quite nice and much cleaner as well. So let's scroll down to this other class. So this class is deriving from the base class. It also defines a constructor. It calls into the base constructor. It defines some other properties. You know the spiel. So again, I can apply my fixer here, and lo and behold, it will lift the constructor parameters to the class declaration. And what has actually happened here is that the base constructor invocation has fused with the subtype declaration. So everything goes into one line, everyone's happy. It's assigning the right value to the relevant property in this current class. Nice. Let's move on down to, am I going too fast?
This is fine.
Cool. So let's move down to yet another class. This one, again, pretty much the same structure as the previous one, but it also defines a private field here. And that private field is apparently referenced by this method here. Again, what this class is going to do doesn't really matter. But let me again convert this to primary constructors. Once I do that, it will perform the exact same transformation as before, But I put to you that actually now, this field declaration here is actually redundant. I don't need it. I can actually just delete that. And here, I can replace this field read by just putting the constructor parameter. And at first glance, that might seem a bit absurd, like how can a method read the constructor parameter? And to answer that question, basically I'll tell you that the parameters in primary constructors serve a dual purpose. They're both parameters and also fields. In other words, if C# detects that you're using a constructor parameter as a field, it will emit a field under the hood and map the constructor parameter to it, so that you don't have to do that. Which is actually quite nice. This basically means is that these constructor parameters are scoped across the entire type definition, which is something that I really enjoyed using in languages like Scala and Sharp, for example. And I guess I'm just going to give you a final example, speaking of primary constructors, just to give you a caveat. At the moment, as the current implementation of primary constructor stands, you can't actually use primary constructors for everything. If your constructor actually contains code other than data assignment, then this code cannot be converted to a primary constructor. Here, for example, I'm doing some parameter validation and throwing if the value doesn't match as well. This in fact cannot be converted to a primary constructor because there's no way to introduce arbitrary code. This is to be fixed in a future release of C#. And as you can see, there's no fixer here, so you won't be able to trip this up over it. If I were to comment this out, well, then the fixer will just happily show here, and it will make the transformation and delete my comment, which is great. No argument validation for it. Cool. So let's move on to my second favorite feature in C#, collection expressions or collection literals. Collection literals are a new language feature that lets you define, well, collection literals using very terse syntax. And traditionally, the way that you would define an array literal value in C# was using the declaration that you see here. Again, because I'm using the latest and greatest version of .NET, I'm getting a fixer telling me to use the shiny new thing, of course. So if I do that, it's going to transform the previous syntax into this bracket syntax, which is essentially collection literals.
That makes me so happy.
Me too, it's nice. It's Python-like, isn't it?
It's looking more like JavaScript.
I mean, there is a bunch of stuff here that JavaScript could do 20 years ago, but we won't talk about that. Because we can do it now with type checking, and that's important.
Nice. And the important thing here is that nothing actually changes in the underlying array. The same initialization will happen as before. So one of the design goals of collection literals is performance in initialization. So you get this nice terse syntax, but you're not making any compromises from a perf perspective. And of course, you're not just constrained to arrays. For example, you can do the same thing for lists. Again, same idea. Again, this will not change the idea under the hood. It will use the same conventions that collection initializing uses. So default constructor add method to populate efficiently, I would say, the list. You can do it with hash sets. Again, same idea. Collections initializer syntax. But what's even more interesting is that you can do it with spans. Strangely enough, the fixer doesn't work with spans, so I need to report a bug here. But if I do it manually, this will type check. And the most interesting thing about this one, I didn't include ISFI in the demo, but if you actually look at what IL is being generated here, this is going to be a stack allocated array using a special intrinsic type. It means that you're able to define spans with really terse syntax in a way that incurs zero allocations for small enough values, that is. But I think where the feature really shines is when you're trying to define really complex forms of data. So here, I'm seeing like this really noisy thing, and I'm basically trying to create a 2D array, but because of all this syntactic noise, I can't really see the data. All I can see is curly braces and the new keyword. So again, if I apply the fixer here, and here I need to do it, oops, one by one. Sorry, I typically use Windows. You get this nice little thing. Now here, the data appears cleanly. Like this is as if I've written a piece of MATLAB. Like this is really clean, and this is I think where the feature really shines. Going forward, you can use it to initialize mutable collections. That has always been a pain. You do it here very efficiently under the hood. You can use it for interfaces. So you can create your INumerable instances or your iList instances, or your iRead-only list instances, and what have you.
What it's used for, iList? Is it create a regularly list?
I will need to see the code, but I would expect that it's using a canonical implementation. It might be using list, but I'm not sure. I will need to double check. One thing to note about target typing is that it doesn't provide a canonical type if you don't specify one. It works using target typing. So if I try to uncomment this, you will see that it will actually produce an error. And the reason behind that is that you need to explicitly declare the collection type that you want to use on the left-hand side. So if I want to change this to, I don't know, I read only list of int, it will type check. But var doesn't work, unfortunately. I guess it's worth mentioning the spread operator as well. The spread operator is this guy here. It's a special operator that lets you splice existing collections into other collections using collection control. So I would probably say that this is pretty self-explanatory. What this will do, I have the code which I won't run at the moment, that shows you that the elements of the outer array is 0, 1 to 3, 0, 0, 1 to 3. So the inner array is spliced in twice. And I guess to conclude collection expressions, I guess I need to talk about how this feature works under the hood. And to do that, I really need to define a custom collection and see how that interacts with this new feature. So here I've defined the simplest collection possible. It's read-only. It wraps an iRead-only collection and implements an iRead-only collection. Very straightforward, but if I try to comment this line here, it will complain. And the reason why it is complaining is that, well, it's complaining that it can't find an add method. So it tries to populate the collection using the standard collection initializer conventions, but because it couldn't find any, it's failing. So let me show you now how this feature typically works and how we've made it work for interfaces, for instance. I have here defined below another static class called myCollection, which defines a single factory method. The factory method accepts a read-only span of values, and then, well, the factory method just populates my own collection instance using these values. And the way in which we get this type to use collection literals is to, well, tell the C# compiler that, hey, you should be using that factory. And the way that we do this is via the new collection builder attribute, which takes a couple of arguments. The first one is the type of the static class, and the second one is the name of the static method. So collection.create. And as soon as I do that, it works. So pretty easy. Now I have augmented my custom collection with collection literal support. So if you have ones in your libraries, do that as well. And I guess to complete this demo, another favorite feature of mine is aliasing any type. So C# has had aliasing for a while, so I could alias integers or strings. But the problem was that you couldn't really use that feature for more complex types. So you couldn't use it for generic types, and most importantly, from my perspective, tuple types. Now, I don't know about you, but in some cases, I actually like using tuples to represent internal state in my implementations. But one thing that's always been driving me mad, at least with C# tuples, is that every time you need to reference that tuple by name, you need to actively expand the full name to be able to describe it. And I guess as your implementation grows in complexity, and if your tuple has more than 3 parameters, like it becomes a no-brainer to stop doing that and just define, I don't know, a struct or something. So let me just do that. I'm just going to do like a regular struct we call range, and it will just have the same parameters. And then if I just, sorry, my VS Code skills aren't the best, so I'm just using primitive ways of finding placement. What am I missing? This guy. So my typical approach would be to just give up, define a struct that contains the data, and use that internally. But now, thanks to C#12, you don't actually need to lug around these additional types that you never needed. You can just go ahead and use tuples. So I'll just do that, and I'll just instead wrote Greek for some reason. In case you didn't notice, I'm Greek. And now I've been able to alias by tuple to the name range, which is easier to generally handle. And I think my favorite bit is that the alias actually also stores label metadata. So in fact, it actually remembers that the second parameter is called offset, and I can just reference it. So I'm really happy with this new feature, and I think I'm going to be using it. How much time have we got?
As much as you like, as long as it's like this.
That's my
This is awesome. Now we get another 10, 15 minutes if you need it.
All right. So I guess I'm going to run out of time and talk about my stuff.
Sorry.
What can you do?
I mean, it's really a question of when FundDeps want to kick us out of the building, so it's kind of down to them. I'm not in a hurry, so.
All right. So let's talk about libraries then. So I'm gonna start with frozen collections. Frozen collections are a new kind of immutable collections that are being shipped in .NET 8. They are data structures that have been optimized for reads. There are currently two types of these available: frozen dictionary and frozen set. The syntax to create a frozen collection is, there's really only one way to do it. There's a few extension methods acting on the source enumerable, with some delegates optionally, and out they spit some implementation of either frozen dictionary or frozen set. There's no constructors, there's no types that you can instantiate, nothing like that. And the question is, like Eric, you already have immutable collections. What's the point of adding yet another set of immutable collections? And well, the answer to that question is, if you actually, I think some people haven't necessarily noticed that, but if you look at the APIs exposed by, say, a type like immutable dictionary, you will see that it actually contains a number of methods that you would typically associate with mutation. So immutable dictionary has an add method. But make no mistake, this add method isn't actually mutating the source dictionary. What it does instead is that it gives you back another version of the same dictionary, but with the new entries appended. Now you might expect that, oh my, this must be really expensive, because clearly it's just copying the entire dictionary, jamming in two more values and giving you back a new copy. But that's not the case. The way that some, not all, immutable collections work is that the two versions, the previous one and the next one, share a substantial amount of state. And they do this by using an immutable variant of AOT trees. And this technique is in fact pretty common in immutable collections, and it's known as persistable updates or non-destructive updates. But that comes at a trade-off. Because, like I said, immutable dictionary isn't a proper hash table. A proper hash table could not support this type of operation efficiently. Because it's using an AVL tree, it means that lookup is compromised. It takes logarithmic time asymptotically to look up an entry. Well, this slide pretty much recaps what I just said. But there you go. So this is what immutable dictionary looks like. Are there any questions about immutable dictionary, non-destructive updates? Cool. So frozen collections then. Frozen collections sacrifice the ability to make updates. So you create an instance, it's got some values, that's it. You can never change it. And the trade-off for that is that it absolutely optimizes for read performance. And it does so by optimizing both for key type and for the actual values that are being passed to the particular collection instance. And it will do so by, at runtime, looking at the actual values and picking tailor-made implementations that are optimal for this particular data set. So it might, for example, decide that one input is too small, so a hash table doesn't make sense. I'm just going to do linear search. It might decide that the key is a string, and there's variation in the length, so I'm going to bucket by string length, and that actually saves a lot of cycles because you don't need to do hashing of strings. And it's doing a bunch of tricks like that dynamically, depending on the values that you give it. And I've taken some benchmarks from Taub's blog, and basically what you see here, this is comparing immutable dictionary with dictionary and frozen dictionary. And not only is frozen dictionary like substantially faster compared to immutable dictionary, it turns out that it's even faster than your regular immutable dictionary. And the reason behind that is that the dictionary can mutate. The hash table can lose balance, like all sorts of things can happen where lookups cannot be optimal. Frozen collections don't suffer from this. And so they actually are an excellent choice if you want to define some sort of immutable cache that spans the lifetime of your application. Probably don't use it on your DTOs because it doesn't make a lot of sense. Just use it for caching. On to the next topic.
Do you have any optimizations around like static frozen dictionaries, etc.?
Static frozen dictionaries?
Yeah, so ahead of time compilation, say for example, you've got like a small.
No, it's all happening at runtime. No, so it doesn't. So you're saying a source generator that builds frozen collections?
So if you've got some optimizations around the size or the type of dictionary or list or set, etc., you've got some optimizations that look at the static.
Yeah.
Look at static, declarations.
These
where you may have like 5 or 6 items in the list.
The answer is that it's probably not necessary because these types of analysis can be supported in AOT as well. So it does do a minimal, I wouldn't call it reflection per se, but it does some sort of introspection of the type in a way that actually works. So it doesn't do anything combined, is the answer. Huh? Cool. Who has called this method before? Can I see the raise of hands? Configure weight. So this is I'll say it's a fairly controversial method. And I guess one of the controversies typically lie around its name, like why call it configure await when it just accepts a bool? Like, well, why is that? Why don't you call it, I don't know, do not capture on current context or something like that? And the answer to that question is that when this was being designed, the plan was to actually expose more options as you were configuring your awaitables. But these ended up being cut solely because it was this one boolean. Happens. So with .NET 8, we're shipping a new enum, aptly called configure await options that adds 2 more flags that you can control. Suppress throwing and force loading. And of course, there's a related overload that you can use in your tasks. To show you how suppress throwing works, suppose you want to await a task, but you want to await on it without any potential exceptions unwinding the stack of your current async method. You just want to await on it, but you don't want the exceptions bound up. And typically, the sort of fastest way that we knew about to achieve this, without incurring sort of additional allocations by wrapping your task into another task, was to do just a try catch and eat the exception. And truth be told, like we had this code in quite a few places in the VCL as well. But this isn't necessarily bad, but one problem is that it actually involves throwing an exception. So, there are some CPU cycles wasted in that thing. So now, by having this suppress throwing flag, you can emulate the exact same behavior by just configuring your awaitable to never throw. So we did replace a bunch of places inside our own libraries to just use that. So, nice. And I guess going through the final option, I think this might be a bit esoteric, but if you've ever dug into async state machine implementations, you might know that if a state machine is awaiting on a task, and there's the possibility that the task has already completed, what the state machine will do is that it will just fetch the value and continue executing on the same thread. Generally speaking, that's a great optimization. You generally want to be doing that. You don't want to schedule your continuation in the thread pool every time you are working on a task, generally speaking. But there exist a few cases, and maybe to show you an example of why that is the case, is that if you try to run the snippet here, where you just print the managed thread ID and then you await task.completed task, which is your canonical task that has completed and has a result ready, the second time that you print the managed thread ID is always going to be the same number. But there might exist a few cases where that is not desirable. One example is that you want to run an async method using fire and forget, and you don't want to bother putting your code into a task.run lambda. And with the new force yielding option, you get precisely that. So if I were to run this second piece of code with configure await force yielding, there is a very high possibility, especially if this is just that is your console app, that you will get a different number in the second time, meaning that the continuation was actually scheduled in a thread pool thread, if it wasn't a thread pool before. Anyways, that's basically the gist of force yielding. Very quickly going through system.json, we invested heavily, like I said before, in source generator improvements. We added support for populating read-only members. So if you have a pogo with a getter that has, I don't know, some kind of readable object, but it doesn't have a setter, then you can instruct the serializer to just populate the values of the value that already exists there. It wasn't a thing, now it is a thing. We've added support for unmapped member handling, which means that you can instruct the serializer to fail if the serialization happens and there exists a JSON property that cannot be mapped to some property in the protocol. Many people have asked for that. And we've also added naming policies for snake case and kebab case property conversion, which is accompanying the existing camel case naming policy that we have. I wrote an article about system.json. So if you would absolutely care about these details, just find the article. I've also been giving a talk in .NET Conf about it, so I'm not going to go into system.json anymore. What time?
We're good.
Okay. I guess a final thing is that after many years, we made a few additions to data annotations, I guess. So who's using system component mode data annotations to do validation? So we've extended the range attribute to add support for exclusive bounds. So in this example that I've defined here, every value between 0 and 1 is accepted, but if it's actually 0 or actually 1, it gets rejected, if you need that. We've also added a length attribute that combines specifying lower bounds and upper bounds for the acceptable lengths for a collection or a string you are trying to validate. We've added allow list support, and we've added deny list support. Basically, the values specified are either only allowed in the first case or they fail validation if they're specified in the latter case. There's also time provider. So apparently, we shipped a new type in .NET 8, which adds a time abstraction, which lets you mock for system clock, time zone, and timers. I had a demo, but it would take too much time, so I'm going to skip that. So I'm just going to go to some links. I know that you can't see URLs, but if I actually put the URLs, you wouldn't be able to type them in anyways. So I just Google these things. Do follow the announcements in the .NET channel. If you go there, you will find links showing you all the details about ASP.NET Core features, Blazor features, MAUI features. Also, we've created some documentation in the Learn website. And if you haven't already, strongly recommend reading Taub's performance improvement scrolls. Like, if anything, it will give you a glimpse as to how the inner workings of .NET runtime are structured. So really educational. Like I said, there's a conference coming up. It coincides with the release of .NET 8. It's free to subscribe. I'll be speaking. And finally, we want your feedback. So if you're using .NET, .NET, whatever version of .NET, and you have an issue, you have a complaint, you're really desperate for a specific feature, come to GitHub, file an issue. We'll definitely look at it and we'll definitely consider implementing it. Also, if you'd like to contribute, we have a bunch of open issues in .NET Runtime. Some of them, that's an understatement. Some of them are tagged with the help bulletin label, which means that like if you want to pick something up and learn how .NET works, like just find an issue that you like, and ask us if we'd like to review a PR of yours. And finally, if you want to give some feedback in private, find me after the talk, probably in the pub. Finally, .NET 9 development is underway. It's the funnest side, I promise. What time is it? Oh, midnight.
1 minute to 9. It's perfect timing.
Awesome. So I took this screenshot yesterday. We have almost pushing, we're close to 200 merged PRs for .NET 9. So if you want to influence the direction of the next release, now is the time to get involved, actually. And with that, thank you.